Hello. The objective of this video is to translate between graphical and algebraic representations of linear functions. Linear functions are linear because when you graph them, they form a straight line. Now, we last learned about how to convert tables to expressions. And we did that by looking for that change. Going from this point to this point, we have a plus 5. 12 minus 7 gives me the 5. Going from here to here, we have a plus 5. From here to here, we have a plus 5. And that was known as the common difference. And from here to here, we went up by 1. And here to here, we went up by 1. Here to here, we went up by 1. And we learned about the expression where we took the first term, 7, added the common difference, which in this case would be the 5, times n minus 1, and we got an expression for that table. Now, we also talked about in class how we use the distributor property to simplify this, and we get 7 plus 5n minus 5. We combine these like terms out here, and we get 5n plus 2. Well, looking at that, wouldn't it be nice if we could go from this straight to this rather than having to do this simplifying in between? There is a way. In fact, the other way may not be any more complicated than this way when you start thinking in terms of tables that don't start at the first term. For example, here we have one that starts at term 2. Using the other expression here, the term 1 would not be this one. I'm going up by 4 in this case. So in order to find out what term 1 is, since going in this direction, I'm adding 4. In this direction, I'm going to do the opposite. To going back to term 1 would be going down 1, which means going back to term 1 from here would be subtracting 4. 9 minus 4 is going to give me 5. So my first term in the old expression would be 5, and I have 5 plus the common difference of 4 times n minus 1. Well, we took away one of those common differences to go back one term. Isn't that what we're doing when we simplify this expression? All we get is this 4 times the common difference times the n minus one of the common differences from the first term. Well, if we think of going back one more, that would take us from the first term, term 1, to term 0. Going to term 0, we take one more, in this case just one more of the common difference away. From the 5, we end up with a 1. So we end up with, in this case, it's going to be 4 times n plus 1. That is this expression simplified, but only going one step. I went back one further to get to the 0 term. This went to term 1. This is going back to term 0. Hopefully you'll see this as we do it in class going over examples. It's not as easy getting it from the first try through. We're going to look at it again, but first this whole objective of this video was to go from graphs. And I went back to tables. I did that because the first step with the graphs is to make a table out of it. So here we have a graph where we have 4 points on there, and we're going to put those 4 points in a table to help us get the expression. First point is 1, 4. 1 for the x, 4 for the y. Next point is 2, 8. 2 for the x, 8 for the y. Next point is 3, 12. 3 for the x, 12 for the y. Next one is 4, 16. So I simply read the points and put them into a table. Then I use the table to create the expression, working with common difference times n plus the zero term. Right, the common difference going from here to here, 8 minus 4 gives me 4. 12 minus 8 gives me 4. 16 minus 12 gives me 4. The common difference is 4. So we have 4n. Now the zero term, this is term number 1. Term number 0 would be one more before it. So instead of going up by 1 like I have in here, I would go down 1. Instead of going up by 4s like here, I would go back 4, and I would get 0. 4n plus 0 would just be 4n. And there would be my answer. Is the zero term always going to be 0? No. In the previous example, it was not. In this one, it just happens to be 0. Okay, we're going to bring that graph back up here. We're going to change some of the values. This is going to be the u-do. I want you to take a look at this graph and give me the table, then the expression from it. Number 1 is going to be at 15. So 1, 15. 2 is going to be at 12. 3 is going to be at 9. 4 is going to be at 6. Pause the video, do the table, write the expression, and we'll look at it in a minute. Welcome back. All right. We're going to plot those points in. 1, 15, 2, 12, 3, 9, 4, 6. We no longer need the graph. Now we can work with just the table. First, the zero term is going to be 1 back from there. The common difference is going to be the 12 minus the 15, which means we're actually going down. So we have a negative 3 times n plus the zero term, which would be actually 3 more than 15 because we're subtracting the negative 3, which makes it 18. And there is our expression for that graph. We'll go and do more examples in class. Remember, the best way to do math, to learn math, is to do math, so you really need to practice this stuff.